Hello students. Today I will start discussing on exercise 13.2, which is actually based on calculating the volumes of combination of solids. Okay, but before that, you should go through the solved examples which are already given in your NCERT book based on this topic. Okay, I'm starting with question number 3. Okay, the question number 3 is a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends, with length 5 cm and the diameter is 2.8 cm. Okay. Beside the question, one figure is given. You can have an idea of the shape of the gulab jamun from that image. Okay. Now, this is the actual shape of the gulab jamun given here. Here you can see according to the question, this gulab jamun have these are two hemispherical ends, okay, and this is the cylindrical part, and the length is given as 5 cm and diameter is 2.8 cm. That means the total one is 2.8. So this much is 1.4, right? And see, since it is a hemisphere, so this is also equals to the radius, right? So this is also 1.4. That means 1.4 centimeter, right? Okay. Now there are 45 gulab jamuns in total, and 30% of its volume is syrup. Okay. So I have to calculate the volume of one gulab jamun at first. Okay. This much length is 1.4 and this is also 1.4. So what will be the length of the cylindrical part? The total one is 5, this is 1.4 and this is 1.4. Length or height, you can say height of the cylindrical part (5 minus 2 into 1.4), that is 2.2, right? So this much height is 2.2 centimeter. Okay. Now let's calculate the volume of the one gulab jamun. Here, the volume of the hemisphere will be doubled because there are two hemispherical ends. 2 into volume of the hemispheres plus volume of the cylindrical part. Right? This will be the volume of one gulab jamun. Now see, they have written I have to calculate the volume of 45 gulab jamuns, right? So what will be the volume of 45 gulab jamuns? Let's make it 45. Multiply this one with 45. Right? Cubic unit. Right? This will be the volume of 45 gulab jamuns. Now, let's put the values here according to the formula. This will be 45 into volume of the hemispheres. Okay, the formula for the volume of hemisphere is 2/3 of pi into r cube. Here r is the radius, that is 1.4 centimeter, right? Plus volume of the cylindrical part. Volume formula for the volume of cylinder is pi r square each. Here r is again 1.4 into h is, I have calculated here, height of the cylindrical part, that is 2.2 centimeter cube, right? Now you can see here pi into 1.4 whole here it is cube and here it is square, so I can take common as pi into 1.4 square. Okay, let's take that as common. And the remaining part is here. Let's make it 4/3 into 1.4 plus 2.2 centimeter cube, right? Now see what is the value of pi here. It is 22/7. 1.4 square, that is again 1.4, and with that I can write 5.6/3 plus 2.2, right? Now so 45 into 0.2, that is 9 into 22 into 1.4, and this will become 6.6, that is okay. Now this will be 66 into 1.4 into 12.2 centimeter cube, right? Now they have said that 30% of its volume will be syrup. So volume of syrup, sugar syrup, will be 66 into 1.4 into 12.2 into 30% means 30 by 100 centimeter cube, right? Now let's calculate this. It will be again 66 and 3, 98 into 1.4 into 12.2 by 10. Let's make it 1.22. Okay, centimeter cube. Now do this calculation by yourself. Here they have said I have to find out the approximate value. Okay, maybe here we will get some decimal expression and then we will have to calculate in the nearest approximate value. Okay, that will be the required volume in the centimeter cube unit. Now question number 5. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. Okay. They have given that there is an inverted cone whose height is 8 centimeter and radius of its top is 5 centimeter and the top is open. That means we can drop anything here in this vessel of the shape cone shaped vessel. Okay. Now we have said that it is filled with water up to the brim. That means it is totally filled up with water. Okay. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of water flows out. Okay. Suppose in a vessel I have filled up this vessel with totally this vessel with water. Now I am dropping some lead shots here, which is of spherical shape, or suppose I am dropping anything here in a totally filled vessel with water. Then certain volume of water will flow out, right? If the vessel is totally filled up with water, right? And that volume that flows out will be equals to the volume of the lead shots, right? Same thing happens here. Volume of water, some certain volume of water will flow out, and that much volume will be equals to the volume of the lead shots. Okay. Find the number of lead shots dropped in the vessel. That means I don't know the number of lead shots which are dropped into the vessel. I have to calculate that one. I have to find out that the number of the lead shots. Okay. Now, for this, let's write which things are given here. Okay, this is question number 5. Radius the cone are 5 centimeter. Height of the cone is 8 centimeter, right? And radius of the lead shots is given as 0.5 centimeter. Now, they have said that 1/4 of the 1/4 of the water flows out if I drop the lead shots in the cone. Okay. So the volume of the water that flows out is equals to 1/4 into the volume of cone, right? This will be 1/4 into, what is the formula for volume of the cone? That is 1/3 pi r square h centimeter cube, right? Now one by 4 into 1/3 into pi into r is 5 centimeter square into h is 8 centimeter, right? So this is 5 square is 25 into 250 pi by 3. Right? This is the volume of the water that flows out. Now, the radius of each lead shots is given 0.5 centimeter. So, these lead shots are of spherical shape, right? So, volume of the sphere, formula for the volume of the sphere, that will be volume of each lead shots will be 4/3 pi into, here r cube means 0.5 whole cube centimeter cube, that is 4 into pi into 0.125 by 3 centimeter cube, right? If I take out the point, it will be 1000. From 25, it will become 10, 5, 2. So pi by 6. This is pi by 6 centimeter cube, right? This is the volume of one lead shot. Now I don't know how many lead shots are dropped into the conical vessel. So let's take the number of vessels number of lead shots be n. Okay, so according to the question, n into pi by 6 will be equals to 50 pi by 3, because this is the volume of one lead shot. If n lead shots are there, the volume of n lead shots will be n into pi by 6, and that much volume will be exactly equals to the volume of the water that flows out, that is 50 pi by 3. So I have written both of them equal. Okay, from here we can have n equals to 100. This is the number of lead shots. Okay. Now question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm. Okay. Is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 cm and its height is 180 cm. Okay, that means they have given a cylinder whose height is 180 centimeter. Okay, and the radius is 60 centimeter. Now they have placed right circular cone which is standing on a hemisphere which touches the bottom, and the hemisphere is upright. That means the hemisphere is like this. Okay, now on this hemisphere they have placed a cone. This cylinder, previously it was initially it was filled with water. When I placed the hemisphere and the cone, then a certain volume of water will flow out or come out from this cylindrical solid or cylindrical vessel. Then the flowed out water, the volume of the flowed out water will be equals to the volume of the cone and plus volume of the hemisphere, right? Here the total height is 180, and the height of the cone is given as 120 centimeter. So this total is 180 and this much is 120, so remaining part is 60. You can also say that the radius of the cylinder is 60, which is also the radius of the hemisphere, and since it is a hemisphere, this much distance will be 60 centimeters, right? Okay, now I have to calculate the volume of water left in the cylinder. So initially it was totally filled up with water. Now after placing the cone and hemisphere in it, some amount of water flowed out. and I have to calculate that flowed out water. Okay. Now the volume of water that flowed out what is the volume of cone? 1/3 pi r square h, right? Here r is 60 centimeter into h. Height of the cone is 120 centimeter, right? With that I have to add the volume of the hemisphere, that is 2/3 pi r cube. R is 60, right? This is centimeter cube. Okay. Here this is the height of the cone. This is the height of the cylinder, and the radius for the hemisphere, for the cone and for the cylinder all are same. The radius in all the three cases is same, right? So let's calculate it. 1/3 into pi. Here I have pi r square pi cube. Okay, let's break it. Then 60 square into 60 into 2. I have break this 120 into 60 into 2. Then 2/3 pi into 60 into 60 cube centimeter. It will become 1/3 pi 60 cube into 2 plus 2/3 pi into 60 cube centimeter cube. That is equals to, let's take 1/3 pi 60 cube common. It will be 2 plus 2 same cube. So 2 plus 2 4, 4/3 pi 6 into 60 cube. This is the volume of water which flows out when I place the cone and hemisphere in it, in the cylinder. Okay. Now I have to calculate the initial volume of the cylinder when the cone and hemisphere was not in it, were not in it. Okay. Initial volume of the cylinder equals to, what is the formula for the volume of cylinder? That is pi r square, that is 60 square into h. Here h is height of the cylinder, that is 180 centimeter cube, right? That will be pi 60 square, break this 180 into 60 into 3 centimeter cube, that is pi into 60 cube into 3 centimeter cube. This was the initial volume and this volume flowed out. So the remaining volume will be this minus this. Okay. I have shortage of space here. Okay, I'm erasing it. I'll do the remaining calculation here. Remaining volume pi 60 cube into 3 minus 4 by 3 pi into 60 cube. Centimeter cube. Okay, that is, take pi into 60 cube common, is 3 minus 4 by 3 pi into 60 into 60 into 5 by 3 centimeter. Sorry, here will be another 60. This is nothing. So 5 into 20, 100. So 100 into 60 into 60, that is 3600, and 2 zeros for 100 pi centimeter cube. Okay, or you can write 0.636 pi meter cube, or you can put the value of pi as 22 by 7 if you wish, okay. This will be the volume, remaining volume.